Hello everyone, this paper is about evaluating the environmental performance of Mashrabiya. Mashrabiya is a common word for traditional perforated screens, which is taken from the word sharab, which means in the Arabic language cold drink, referring to the function of the ceramic pot that used to be placed in the Mashrabiya in order to cool the air entering to the space and also cool the water for drinking. Mashrabiya does not only reflect the passive environmental solutions, it also reflects the cultural and social aspects of the regions. That's why it varied in the terms of geometry and pattern from a place to another. The Andalusian Mashrabiya, for example, located mostly in Spain and Morocco, is common for its floral patterns and symbol geometry, while the Ottoman Mashrabiya was much more complex in geometry and much more simpler in the patterns. The contemporary implementation of Mashrabiya became just a perforated screen as a part of double facade. That's why we needed to study the old examples of Mashrabiya in order to reintroduce it. For that, the field work was held in two different parts of the world. We started by Spain, going to Granada and Cordoba to study the Andalusian Mashrabiya, and then we moved to Cairo to study the Ottoman Mashrabiya. We didn't only monitor the environmental performance of Mashrabiya, but we documented the different forms, different patterns, and we started noticing the aspects behind choosing these forms and patterns. The Andalusian Mashrabiya was much simpler in the pattern and geometry, and this did not allow to use a lot of ventilation techniques, so it depended mostly on the creative architectural design of the space. For example, to create a stack ventilation, there was a bigger window with lower perforated screens and a smaller window with higher perforated screens on top of it, like in Alhambra Palace and Ambassador Hall. After that, the Ottoman Mashrabiya, due to the complexity inside the component, it allowed the architects to use more than one pattern in the one component. This variation in patterns and perforation percentage allowed the architects to create the source of stack ventilation through the component. However, for some deeper spaces that have deep width and deep area, and a smaller window was provided on top of the component in order to allow more air flowing through the whole depth of the space. So, in the field work, we noticed Mashrabiya, we observed its environmental parameter, we also documented all the examples that we had met. We were focusing on how to remodel such a complex components in different analytical softwares. For that, we talked with the craftsmen, we visited the workshops, and we asked them about their opinion on how they create the patterns itself. What are the standards they are following, and what are the precautions they follow in renewing the old ones? The craftsmen also helped us to create a new model that we took with us and we tested it in different environmental parameters. The field work helped us to understand the disadvantages of Mashrabiya, like for example noise allowance, maintenance problems, as well as fire and safety issues. All these factors helped us to set the methodology for quantifying the Mashrabiya using analytical tools. We started by selecting 7 common patterns that is used widely on Mashrabiya manufacture, and then we analyzed the component that forms each pattern. We analyzed them in terms of shading performance and ventilation. After that, we provided a design catalog for the users to use for contemporary implementation. On the micro level, we started taking the component that forms each pattern and being repeated on a bigger scale. Then we put that component on a show box or a test box where we can test these components under the same environmental parameters that we set. The idea behind choosing the component that forms each pattern is that a pattern like arabesque, for example, the pattern look very similar in different case scenarios. However, the performance varies so much because the component that forms each pattern is very different on the small scale. For the ventilation studies of this component, we studied the discharge coefficient because we found it would be very efficient in studying something on such a small scale. Based on these results, we started gathering them. For studying the shading, we started studying the average luminance that passes through each pattern and also the vertical solar radiation. Zooming out and studying the Mashrabiya on a micro level, from the living case examples, we can say that Mashrabiya is pretty complex component. it can gather different patterns with structural forms. That's why we needed to test this combination of patterns. So, we started by testing how one pattern will perform in terms of ventilation using CFD analysis. But when we combine two patterns together, a stack ventilation helps the air flow through the whole depth of the space, which is more efficiently performing than the first case scenario. Testing how the pattern will perform in terms of evaporative cooling. Adding a ceramic pot in front of the inlet makes the air much denser to go through the whole depth of the space. However, using evaporative pattern like EvaCooler pattern makes the air much denser, but it goes through the whole depth of the space in a more efficient way. During all of these analytical tools, So basically, we understand that Mashrabiya is an idea developed from a normal horizontal fin, and it is a perfect solution for both western and southern facade. That's why we wanted to develop a formula that can link the length of a horizontal shading fin to the perforation percentage. The formula will help the user to determine what is the perfect perforation percentage required for a proper shading of the window. However, this formula depends on a variable, and this variable changes according to how much we want the air penetration and the view. We also gave some recommendations based on how to design your shading element. For example, inclining the shading element helps to reduce the amount of sunlight passing through it. Working on the micro level, we can say that if you crafted the wood with a little bit of inclination, it can prevent more than 40% of the sunlight angles that enters through the pattern, and we can say that this is a perfect solution for low sun incidence and the western facade shading element. In the end, we gathered all the results in a matrix that portrays all the work that had been done in this research, and it can help the designers to choose the most suitable pattern for their facade. Thank you so much. I hope you enjoyed.